Okay guys, so I'm continuing on with part 3 of the Unit 6 Day 1 lesson, and we were talking about how the acceleration is the rate of change of the velocity. So if we were talking about average acceleration, and that would be kind of like the slope of the secant line of the velocity graph. So here we could say that A equals delta V over delta T. And this would be like in advanced functions when we talked about the average rate of change. The instantaneous acceleration is what we're really going to want to be looking at, because that's really what the heart of calculus is talking about the rate of change of those functions, how the functions are changing over time at that instantaneous point. So the instantaneous will be a function acceleration that's v prime at t, or we can also write that as dv dt. Okay, so the two really important things in this day are that the velocity function is the derivative of the displacement function, and that the acceleration function is the derivative of the velocity function. And that can also be written, obviously, that we're taking the derivative of displacement to get velocity, then we're taking the derivative of velocity to get the acceleration. That's what's called the second derivative, because we're taking the derivative of my displacement function to find velocity, then I take that new derivative and take the derivative of that to find acceleration. So we can also write this as s double prime, two little tick marks there that says I'm doing the derivative of displacement twice, and that gives me my acceleration function. So this second derivative here, that little comment, just to make sure you understand what that is in general, that would be written as f double prime at x, or d2y, d squared y by dx squared. So it's the change in y twice over double the change in x. So we are, sorry, not double, by the change in x and the change in x again. So it's talking about how the derivative is changing. That second derivative, we're going to look at that more in the curve sketching unit next, in unit 7, but that's going to talk about the rate of change of the derivative, not the rate of change of the original function, but kind of the rate of change of the rate of change. And that's what acceleration is a real life example of. Okay, so pretty simple example here for the first one. It gives a displacement function that's a cubic. So we can say the first derivative, s prime, and we can also label that as v at t. That's the same thing. And we'll just do the derivative of this cubic, 3t cubed minus 6t squared plus 2t minus 1. So my derivative is 9t squared minus 12t plus 2. So that's the first derivative. The second derivative, or the acceleration function, would be 18t minus 12. Okay, so we can use these to figure out a lot of different things about the movement of along that straight line, and how the speed, the velocity, and the acceleration are changing over time. Okay, I'm going to take a little look through this chart and think about what the velocity does and what the acceleration does in terms of where this is moving. So here, if the velocity, we know that if the velocity is less than 0, your position time graph will have a negative slope. We looked at the example at the very first video there. And on a number line, it's moving negative. Which is left or backward. Okay. And if the velocity is positive, then it would have a positive slope of the position time graph. I can spell. So a positive slope, and it's moving forward or moving positive direction, which is right or up. And the third possibility for velocity is if it was equal to 0, that would mean that it was stationary. And sorry, that should go over there. So this would be a 0 slope or horizontal. It's also important to be able to tell, I'm just going to flip to the next page on this, what's happening with the acceleration. So if the acceleration is negative, so if the acceleration values are negative, that means that the velocity is decreasing. Now, decreasing velocity doesn't necessarily mean that that would be a decreasing speed. Remember that if your velocity was -10 and it decreased to -15, you're actually moving faster, just in the negative direction. Same thing here, if the acceleration was positive, the velocity is increasing. And if the acceleration was equal to 0, the velocity is constant. So if you're speeding up, we kind of refer to that as the magnitude of the velocity is increasing. So the magnitude of the velocity, or the speed, is increasing. That can happen in two ways. That can be if Vt is greater than 0, so the velocity is positive and the acceleration is positive. I'm going to put a little and there. So the velocity is positive and the acceleration is positive. So if I kind of draw here, my velocity is moving in a positive direction and it's accelerating in that direction, you're going to be speeding up. Or that can also happen, and I'm going to have to kind of squish this in here, that can happen when the opposite is true. So if the velocity is negative and the acceleration is negative. So if both of those things are negative, that's also going to make you speed up. So looking kind of on a number line or on this straight line motion, if your velocity is moving you in a negative direction and your acceleration is decreasing your velocity, so that would be like an example of velocity going from that -10 meters per second to -15. It went down by 5, so the velocity decreased, but it's actually going faster if you're talking about how that thing is moving in the world. So basically, if the signs match, that's what you're looking for. Velocity and acceleration are both positive, or velocity and acceleration are both negative. That means that you're speeding up. Slowing down is really just the opposite. The magnitude of the velocity is decreasing, And that would happen if, say, the velocity was positive and the acceleration was negative. So if you're moving along this number line, my velocity is moving me in a positive direction, but the acceleration is decreasing it. So maybe the velocity went from a positive 20 to a positive 18. It decreased by 2. It's going slower. Or that could also happen in another case if the velocity was negative and the acceleration was positive. So here, if you're moving along in a negative direction, but your velocity is increasing. So say if you had v was negative 10 and then v is negative 7, that's an increase of 3. So you've increased your velocity, but you're actually going slower because you were going in the negative direction. Okay. The last thing I'm just going to add, and it's not actually in the note, is talking about moving away from or towards the origin. So I'm just going to kind of do the same idea. So if you want to know, are you moving away from the origin? So there's two choices here. We're not going to be looking at acceleration in this case. We're going to be looking at position and velocity. So if that's my origin, maybe my position is in a positive side of, in a positive value. So here, S at t is positive. If this is moving away from the origin, my velocity would be positive to make it go further away from the origin. Okay, so that's one case. So basically, if S is positive and V is positive, that's both moving. You are in a positive direction compared to the origin, and you're moving more in a positive direction. So you're going away from the origin. The other case could be if you're over here. Your position is in a negative position. You're at a negative value, and your velocity is negative. So you're moving in a negative direction. So these two together, either position and velocity are both positive, or position and velocity are both negative. That would both be cases. So position and velocity both positive, or position and velocity both negative. Both mean that you're moving away from the origin. The opposite of that, where you'd be moving towards the origin, would be the first case. If your position here was positive, if you wanted to move towards the origin, you'd be moving in a negative direction. So that would be a negative velocity. So if your position is positive and your velocity is negative, you're going back towards the origin. The opposite case of that would be if your position is negative and your velocity, you would want to be moving in a positive direction to go back towards the origin. So either one of these cases where the signs of your position, your displacement function, and your velocity function are opposite signs, you're moving towards the origin. And where the displacement and velocity signs are the same, you're moving away from the origin. So that's very similar to the speeding up, slowing down, but speeding up, slowing down is analyzing the velocity and the acceleration.